Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are going to learn how to solve problem sum based on job sequence under the subject operation research. In this sum, we are going to take up sum where we'll have n number of jobs and 3 machines. Again, a very important topic for all the students appearing for semester 6 of TYBMS student. Okay, again, we'll be taking up some rules and thereafter we'll see how to solve the sum when we have been given n jobs and 3 machines. So let us see how to solve the sum.
Okay, today now we'll be solving, problem sums relating to job sequence where there are n number of jobs and 3 machines. Now let us see how to solve when there are 3 machines. Okay, now we'll just go to the question. The question states that there are 5 jobs, 1, 2, 3, 4, 5. There are 3 machines, A, B and C, and then these are all the data given related to the number of hours each job requires by the respective machines. Now the very first step to solve, okay, to solve job sequencing problem and 3 machines are given, the very first step is we will convert the 3 machines into 2 machines. So we'll write here, let machine G be the addition of machine A and machine B, and machine H be the addition of machine B and machine C. So the first step is we are going to convert 3 machines into 2. So we have to make a table. The first heading will be job. So now there are 5 jobs available. We are converting 3 machineries into 2 jobs. So we have machine G and machine H. In order to find the values of G, the formula is A plus B. That is nothing but the addition of machine A plus machine B. So machine A is 8. So 8 plus 5, we have 13. 10 plus 6 is 16. 6 plus 2, 8. 7 plus 3, 10. And 11 plus 4 is 15. Similarly, to find the values of H, we'll have to add B and C. So 5 plus 4, 9. 15. 10, 3 plus 6, 9, and 4 plus 5, 9. So that was the step number 1. So first step, whenever there are 3 machines, convert those 3 machines into 2 machines. Step number 2, we need to find optimal job sequence. Okay, now in order to find optimal job sequence, we'll have to create a table with 5 columns because there are 5 jobs available. The left side represent machine G, the right side represent machine H. Now we need to pick out one by one, starting from the least number of hours taken. If it represents machine G, we'll start from the left side. If it represents machine H, we'll start from the right side. Now the least value available is 8. 8 represent machine G. G means we'll have to start from the left side, and the number of job what is going to represent is 3. So the very first job that we'll have to do is job number 3. Now next lowest is 9. However, I can see there are 3 places 9. So now there's a tie between the number 9. So the rule is whenever there is a tie, okay, check for the opposite side, opposite machinery number, and check which is the least among them. Now here it is 13, for here it is 9, and here it is 15. The least is 10. So this will be selected. Okay, it represents machine H, so it will be from the right side, and job number will be 4. Okay, once you have cleared it out, we cross it down so we cannot use these two again. Now the next lowest is again 9 itself. So again there are 2 9s, so we check the opposite side number. 13 being the lowest, this job will be selected. Again it is from H, so we'll note it on the right side. It represents job number 1, so we'll note down job number 1. The next is again 9, and it represents H, so again we note it down as job number 5. Next is job number 15. It represents, since that was the only place we could have directly written it here. So finally our optimal job sequence is first job number 3, then job number 2, job number 5, job number 1, and job number 4. Now let us see how can we solve in order to get the idle time and the elapsed time. So this is the table that we'll have to create. First column is jobs. Next we have three machines. So we have machine A, machine B and machine C. We'll have to record their in time and out time for machine A, machine B and machine C. Under job column, we'll note down the job sequence that we have already found from the optimal job sequence. So we have 3, 2, 5, 1 and job number 4. So now let us start solving and see how we can solve this. First, the in time of the first machine will always be 0. Now machine A represent job number 3. Now job number 3 states 6 hours. So your out time becomes 0 plus 6, which is 6. We bring it down. This is job number 2. In job number 2, machine A is taking 10 hours. So your out time will be 6 plus 10, which is 16. 16 comes down. Next, 16 plus job number 5 is 11 hours. So that becomes 27. 27 comes down. Next, job number 1 is 8 hours. So 27 plus 8 is 35. And lastly, 35 plus 7, which is 42. Okay. With this, we have completed the working for machine A. Similarly for machine B, the very first in time will be after the out time of A. So A has taken 6 hours, so the in time will be 6. Now 6 plus job number 3 for machine B is 2. So 6 plus 2 is 8. Now the out time of B is less than the out time of A. So whenever this is less than this, we'll have to note down the higher value, meaning there is some idle time available here. 16 plus in job 2, okay, machine B has taken 6 hours. So which is 22. Now 22 being less than 27, we'll have to note down 27 here. So there will be some idle time available here. So it will be 27 plus 4, which is equal to 31. Again 31 is less than 35, we note down 35 here. So there will be idle time here. 35 plus 5 will give you the total out time. So again 40 is less than 42, so we note down 42 here. So there's idle time available there itself. So 42 plus 3, which is 45. Similarly for machine C will start only after machine B gets done. So machine B out time will become in time of machine C. So 8 plus third job 8 hours, so which is equal to 16. 16 less than 27, so we note down 16 less than 22, so we note down 22. So there is some idle time here. Next will be 22 plus, this is the second job, so second job has 9 hours, which is 31. 31 equal to 31, so no issues. 31 plus fifth job has 5, so that becomes 36. Now 36 less than 40, we note down here, so there is some idle time here. So next is 40 plus job number 1 is 4, which is 44. Again less than 45, we noted here, so here there is some idle time. Last 45 plus job number 4 is 6, which is 51. Okay, with this we have completed the calculation. Now let us start finding the final answers. The very first thing was the idle time for machine A. Now machine A is all the values are in correspondence, like 0, 6, 6, 16, 16, 27, 27, 35, 35, 42. So there is no gap in between. So there is no idle time in between. However, machine A got done at 42 hours, but the final elapsed time got over at 51. So there's a difference of 9 hours. So the idle time that machine A had to wait was 9 hours. How we got that? 51 minus 42. Similarly, we need to find out the idle time for machine B. Now, machine B started the very first job at 6 hours. The very first 6 hours it had waited, that was the idle time. Next, from 8 to 16, it had to wait. So another 8 hours it had waited here. Next, from 22 to 27, so another 5 hours idle time. From 31 to 35, again 4 hours idle. 40 to 42, again 2 hours idle. And lastly, 45 to 51, so 6 hours again idle time here. So total 31 hours idle time machine B had. Now, idle time for machine C. Machine C started only at 8 hours. The first 8 hours were idle. 6 plus 22, 16 plus 22, so we have 6 hours idle. 36 plus 40, that is 4 hours, and 44 plus 44 to 45, that is 1 hour. So in total 19 hours idle. Therefore, the total idle time of the machines A, B and C were 9 hours plus 31 hours plus 19 hours, which is equal to 59 hours. So the total idle time we found is 59 hours. Last thing to find is the total elapsed time, that is the total final hours. It started with 0 and ended to 51, so total elapsed time is 51 hours. So with this, we have completed the question solving on job sequencing, where there are n number of jobs and 3 machines. So the first step was convert 3 machines into 2 machines, then find the optimal job sequence, thereafter do the calculation, and then from that calculation find out the idle time and the total elapsed